So good afternoon, everyone. Today we'll be covering 3.4, maybe getting to 3.5 as well. This is on measures of position. And we're going to start where we left off last, which was with the bell-shaped distribution. Remember with the empirical rule? So we're going to deal with the bell-shaped distribution. But we can talk about position in terms of where certain data fall in that distribution. And it's something called a z-score. And so I'm going to start with a problem. And this is in 3.4. They do explain, this is bell-shaped. So it's section 3.4. Page 171, and it's number 8. It's titled Men versus Women. And they start by saying the average 20 to 29-year-old, the average 20 to 29-year-old man is 69.6 inches tall, with a standard deviation of 3. All right, so I'm going to write that down. For the average, this is for a population. I can use mu, correct? 69.6 inches. So there's the average. All right. The standard deviation, 3 inches. So I'll just put SD for standard deviation. They also say the average 20 to 29-year-old woman is 64.1 inches tall with a standard deviation of 3.8. All right, so I'll go over here. 64.1, standard deviation 3.8. That's for women. And the question they're asking in number 8, in these bell-shaped distributions, they're both bell-shaped, who is relatively taller, a 67-inch man or a 62-inch woman? So that's the question we're going to answer. Who is relatively taller? A 67-inch tall man or a 60-inch tall woman? And they're talking about the height there. Who is taller relative to their population? That's the question. Okay, well, they're both bell-shaped distributions. We can make a bell for the men. We can make a bell for the women. And then we'll just look in the bell curve in this distribution. We'll see which one's further to the right side, right? Whoever's higher up this scale, right, is going to win this contest. Now, if it's too close to call, no worries. We'll go to a math formula. All right, we'll use a math formula. But I think it's good to first just look at these distributions. So, and you did a great job building these on your last test. So, let me go ahead and just build a bell for men. And I'll just put men in here. Put a tick right in the middle. A 1, 2, 3, and a 1, 2, 3. What's right in the middle?
69.6.
69.6. For me, right? Now remember, for this, I have to add this. All right, what's 69.6 plus 3?
72.6.
Maybe I won't fill out every tick mark, but I'll fill out a few. I'm going to go 2 standard deviations above the mean. That would be
75.
75.6. This time I won't label the third one. I think I'll just label these 2. And just get a picture going. Pictures help us in stats, help us understand this stuff. All right, I'll subtract 2. I mean, subtract 3 from this, I get 66.6. Subtract another 3, I get 63.6. And this is in terms of height, so that's 5 feet, 3.6 inches tall.
Next one is 666.
Yeah. Right. All right, so there's the distribution of men. Woman? Let's build one for the women. Okay, this is in terms of height. 1, 2, 3. Remember that third tick mark will be right where this is. Now, 64.1 for the middle.
Okay, so.
All right, feel free to use a calculator to help you out here.
67.9.
67.9. Now we got to add 3.8 to that.
So that's 9 plus 87.
71.7?
Yeah.
I would agree. Now for these two, I have to subtract 3.8. Feel free to use that calculator if you want to check it. Because I know you get a 3.8 in there. If you want to mess with it.
60.3.
Oh, 60.3 for this one.
56.5.
And 2 standard deviations below the mean. We're talking about a height that is, what was that?
56.5.
56.5. Looks good. Looks good, right? Distribution of women, distribution of men. Okay, we can come back to this question now, huh? Right? Who's further up that way? True? Relative to their population. I'll use the yellow chalk.
So when
We
you
get to the south. We're just going to see who's further to the right. All right, 67-inch man. Let's make a mark in there. Where would that be about? What about here?
Mm-hmm.
There he is. I'm going to agree right around there?
Yeah.
Ballpark. How about the 62-inch woman? 60.3, 64.1.
Yeah.
Somewhere in here, ballpark. So right now, everyone, do you agree it's too close to call?
Yeah.
From my picture, from me just making an image, it looks like it's too close for me to call, and we're going to have to go to a math formula. No problem. The math formula is going to tell us the answer. And what we're going to do, everyone, we're going to find something called a z-score. A z-score will give us the position of those data values in the bell-shaped distributions. How about that? It'll be a score. And you go, what does it represent? All right, the z-score, you might get a number like 1.5 or 2.3. It could be negative. But what it represents is how many standard deviations that data value is above or below the mean. That's what that z-score is going to represent. I'll say that a few times so you can copy it. We're going to calculate a z-score. You go, what's going to represent? It's going to represent how many standard deviations above or below the mean that data value will be. By being below the mean, it's going to come out as a negative z-score. And by being above the mean, it's going to come out as a positive z-score. Okay? And so I'm going to go in here. You know, where's the math formula? Oh, I'll show you. I'll show it to you. But before I do, I want you to get a sense of what's the z-score going to be?
Relative.
Yeah, it's going to be a value, and it's going to tell us how many standard deviations above or below the mean that data value is represented by. All right. So in our pictures, everyone still got these pictures in your notes? These are x values. All these. Those are all x's right there. You see these? The 56.5 and the 60.1? Those we can refer to as the x values. They're x values. All right? Data values. Well, underneath it, let's write out z. Here, let's put a z. Everyone, right at the mean, in the middle of the bell, z is equal to 0. And at this first tick mark, z is equal to 1. And at this one, z is equal to 2. And at this one, z is equal to 3. How easy is that? These are z-scores. Guess what z is over here, though?
Negative 1.
Negative 1. See, on this side, negative z-scores. Negative 2. And at this location right there, negative 3. So I think we all agree, both of these individuals have negative z-scores, correct? Yeah, very good. They both have negative z-scores relative to the populations. Hey, can you have a z-score of like 5? Sure. Like, does anybody know Shaq from basketball? Maybe he's up at 4.2 or something. I mean, there's some outliers, well beyond what we have here. But remember this? 99.7% of the data's in here, within 3 standard deviations of the mean. But there are some that are way out there. You got higher z-scores. Okay. So over here, I'm gonna do it again. What's z right there? 0, 1, 2. Throughout this whole course, you'll know what z-scores are. You go, oh, they're positive or negative numbers, usually between -3 and 3. You don't have decimals. All right.
They usually say up to 2 standard deviation is natural. Anything beyond that is abnormal.
That's right.
So is that what they use, the z-score or the
That's right. You'll use a z-score to determine it.
Okay.
That was good. So he's just talking about, like, in this world, sometimes we think of things that are kind of rare or unusual. And so we can, for our course, you want to just, for one number for our course, we'll just say anything under 5% chance we can consider unusual. Does that sound good? If there's like something less than a 5% chance. Maybe there was less than a 5% chance that we'd get no snow today. We're like, oh, well. They kept telling us all the snow we're getting, right? I'm looking out and I don't see anything. So maybe it was like a little unusual after all those predictions we heard. Cool. All right, so what is the formula for calculating z? I'm going to put it right over here. Z is equal to, I'm going to put it in words first. Z score equals your data value. I'm going to put it with words first. The data, like that data value, the number given, minus the mean divided by the standard deviation. But that's with words. You could say the mean of the statistic and the standard deviation of the statistic if you want to add stuff. That's with words. So it's data value minus mean over the standard deviation. Let's put it with symbols. Let's start it with samples. What would that be with samples?
X of I.
X minus X with a
Bar.
bar on top all over the letter S. Cool?
Aren't you doing it for, oh, sample, sorry.
That's sample. Now we can write it for a population. And what would this formula look like if it was a population? All right, here's Z. X minus, what was mean?
Mu.
Mu.
Over sigma.
And then this funny lowercase sigma.
Sigma.
There you go. These are on the formula sheet. So if you're stressing, I'm going to forget that, you can look it up on the formula sheet. But that's this math formula for calculating Z. I do want to point out, this only deals with what kind of distribution?
Bell shaped.
Yeah. We're not finding z-scores if the data's skewed. Skewed left or skewed right, okay? We won't even mention z-scores. We'll do something else to find a position. Cool? All right, are you ready? This is what you and I are going to do. Hey, you'll do it on your test, won't you? You'll do the same thing. We're just going to get this z-score for that gentleman right there, and we're going to get a z-score for this woman right here. And whoever has the higher z-score is the answer. Now, if it's a tie, we'll just have to say they're equal and it's a tie, right? That's what we'll do. They come out numerically the same, because that could have happened, true? They look pretty close. All right, let's do it. Everyone, let's get the z-score for the man. That z-score, we know it's going to be negative, but it equals, all right, what goes right here? What was his height?
67.
67. What was the mean? 69.6. Divided by a?
3.
3. Awesome.
Are you supposed to take an absolute value?
No,
No?
because z-score is going to be negative.
Oh, really?
Yeah, z-score is going to be negative. Hey, everyone, I'm going to do this on purpose. This is the professor mess up, right? On purpose. Because I don't want you to do this on your test. Or practice problem. There, all right, I'm getting the z-score. Can everyone see that? Is it showing up? Everyone see it? What's wrong? What's wrong with this? I'm saying, don't do this.
Parenthesis.
Look, I'm just typing it in. I'm going to get my z-score. Don't do this. Order of operations, right? What is it? What happens in order of operations? It does what first?
Division.
Multiplication and division before the addition and subtraction. So how should I type this in? I heard it. Someone said parentheses. I heard it. So I'm going to just clear this out. This should be wrong. I need to put, if I do it all at once, parentheses 67 minus 69.6. Close the parentheses, division of, was it 3? All right, and I'm just going to go up to a couple decimal places. 2 decimal places. Z is roughly, roughly about negative 0.87. Okay? Yeah. Now, and when would you get the z-score for the woman? What was hers? She was 62?
Yeah,
And when she
0.5.
was 62, he was 67. 62 minus, now be careful, don't use the mean of men. Use the mean of women. 64.1, and what was standard deviation?
3.8.
You know my rule. I want one person to get it, and then someone else will double check.
Negative 0.55.
Negative 0.55. Can someone verify that? Is that what you got? Yeah. Awesome. Thanks, Holly. So, Helen got it, Art got it. Negative 0.55. No. We got the numbers. We got to be careful, though, everyone. Negative numbers are tricky. Which one of these 2 numbers on the board is actually higher. Which one is closer to that?
The one on the right.
Yeah, this one. We gotta be careful, you know, gotta be careful with the negative values. This one is actually a little bit greater than that. So this is the winner. This is the answer to the question. So when I answer this, I'm gonna say the woman. The 62-inch tall woman. So if these two are dating and they are having this argument, I mean, yeah, she wins the argument. She's like, we're gonna use statistics, right? She wins. Hey, on a test, on a test, if these came out to be both negative 0.55s, then say they're both the same. They're both the same relative to their populations. Hey, so with statistics, what's very important, understanding what all this stuff means, being statistically literate. So I want to make sure you understand z-scores again. You're like, all right, that's a z-score. And that's, and you go, what does this mean? Let me say it with words again. You go, what does that mean? That gentleman right there is negative 0.87, listen to this, standard deviations below the mean. He's close to 1 standard deviation below the mean. So he is 0.87, let me say it again, he is 0.87 standard deviations below the mean. He's close to 1 standard deviation below the mean. By being negative means he's below. When it's positive, where are they? Above, right? Yeah, so this woman right here, she's roughly close to 0.5 standard deviations below the mean. So when I'm saying this with the z-score, I'm saying 0.55, then I'm saying what? Standard deviations, right? Sometimes people don't understand what a z-score is. They think it's like a percent. No. It just represents position, right? Position. You're 1, you're 2, you're 3. Okay. You were at negative 0.5, you were located right there. So, cool. So let me throw, I want to give you a question. I want to make sure you conceptually understand this concept of z-score. Okay? Can I erase? Mm-hmm. All right, so I'm going to erase. I'm going to give you a story while I'm erasing. Everyone, I went to the doctor yesterday. Oh, Liz, go right ahead. I'm sorry.
Is this always going to be, this z-score always going to be a comparison between two things?
Not always just a comparison between two things. It's going to allow us so many cool things in this course in the world of statistics because it gives us position, and there's so many distributions that are what? Bell-shaped. If you and I look at this and we think, well, this area under this curve, this is what we'll get to later in the course. If the area is 1.0, we can think of that as 100%. And then we look at like probability of things occurring. We can talk about the likelihood of things happening. We really can. We can look at chance. Like, what's the chance this could happen? And you go, well, how are you going to get it? We'll go, get the z-score. We'll see where it is, and we can look at percentages inside these bell curves. Cool? But that's coming up, and when we talk about that probability word. You know, we get the probability to chapter 5. We don't want to rush everything right now. Right now we're just doing position, true? Awesome. Hey, I know for right now, the only percentages we know, Liz, is that 68% of data is within here, 95% of the data is within here, and then 99.7% of the data is in here, and then you might have someone like Shaq who's over here with a height of 7 feet tall, right? All right, here's my story, everyone. Oh boy. I went to the doctor yesterday. You know, annual checkup. Checks me out, blood work, all that. Well, something kind of alarmed him, everyone. It was my cholesterol level. And he says, you teach statistics, right? And I said, yeah. And he goes, it's your cholesterol level. I'm like, oh boy, what? He goes, well, relative to men your age, he goes, your cholesterol level, your z-score is 2.0. Okay, so did everyone hear me? I'm going to give you an A, B, C kind of multiple choice question. I want you to tell me which one of these is the correct interpretation of that. He knows I know because I'm a stat teacher, right? But did you hear what he said when he talking about my cholesterol level? My cholesterol level relative to men my age? And he gave me my z-score after doing a test. And my z-score was what? 2. All right, so letter A, is it this? Is this the right interpretation of that? And when I'm 2 percentage points above all the other men my age? Is that what that means?
No.
No, that's not it. That's not what that means. Okay, he said I had a z-score of 2. Does that mean I'm 2 points? I'm 2 points above men my age? 2 points? No. That's not what it means. All right, letter C. He said I had a z-score of 2. Does that mean I am 2 standard deviations above the mean cholesterol level of men my age? Ding, 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 ding. That's what it means. And you can almost make a picture, right? In your mind, you got this bell, and I'm over there, right? And high cholesterol, not so great, right? You're like, hey, you're something. By the way, I'm lying. I'm making up this story. Although I should check it out, right? I should check it out. So that was the answer, and you're right. I mean, you're making a picture like you're right there, and that's not good. You know, maybe if these are like scores on an IQ test, oh, great, yeah, that'd be super. But no, it was. We were talking about cholesterol level. It's pretty high. I'm way over there. All right, so very good with that. So those are z-scores. Deals with position. But there's other ways to look at position. What if the data is not bell-shaped? What if it's skewed? And so we're now going to look at what's called a 5-number summary. We're going to look at a 5-number summary. But when I talk about 5-number summary, everyone, would you get outside a bell-shaped? It can be bell-shaped, but it doesn't have to be. I'm talking about a 5-number summary. This distribution can be skewed left, skewed to the right, or bell-shaped. All right, so the 5-number summary. There's 5 key statistics. What are they? The min, or the minimum. I'm abbreviating the minimum. Everyone in a distribution, that's going to be the lowest, right? All right, now put Q1. Yeah, Q1, I'll talk about that in a second. The median, I'll just put MED for median. Q3. And the maximum, I'll just put max to abbreviate. And when you say I wrote Q1 and Q3, some students like to write those like this, like a subscript, if you like to do that, but it doesn't matter. It doesn't matter in terms of notation. Put a Q3 right next to it, or a Q with a 1 right next to it. I'll leave it like that. All right, so we're going to look at a distribution, and you and I will talk about, well, what the heck is the Q1 and the Q3, and what does that represent? All right, we'll talk about that in a second. We'll get some numbers here. Get some data off the textbook. Who's got their textbooks? We'll get the data from the textbook. We'll use you okay using calculator to do this? All right, we'll use technology to calculate these values, and we'll talk about what it means. But before I do, how about by hand, if you wanted to do this by hand? Some students like to do everything by hand. We know how to find the minimum. Wouldn't that be the smallest? Mm-hmm. And when you know how to find the maximum, yeah, that'd be the largest. Now, do you recall from the last test, do you know how to find a median?
Yeah.
Okay, good. So what is this thing right here, the Q1? This would be the middle number between the minimum and the median. That's what it is. Q1 is the median between the minimum and the median. That sounds funny, doesn't it? But it's the middle number. So if you want to do by hand, list all these, sort all these, ascending or descending order, and then go find what's the middle number. And guess what Q3 is? That will be the middle number between the median and the maximum. And you'd sort them. You could do it by hand, but please feel free to use technology.
So median is Q2, because I've seen people.
I love it. And hey, we got a new name for median. We can now call it Q2, if you want. You don't have to, but you can. You can call it Q2. Let's put some other names down. I keep saying Q1. You're like, what is that? It's called a quartile. So this is the lower quartile. Let's get some names down. You're the lower quartile. Q1, the lower quartile. So you, Q3, you're the upper quartile. Upper quartile. Lower quartile, upper quartile, Q1, Q3. Hey, here's some other names. We said this represents position, right? We can talk about percentiles. Now, I'm not drawing a bell because the data might be skewed, true? So I'm not drawing a bell. You might have skewed data. Maybe the data went like this. But we're like, where's something at like the 50th percentile, the 25th percentile, and all that stuff. And when we can call Q1 the 25th percentile. What do you think the median is?
50th.
You can call the median the 50th percentile. You go, really? Yeah. You know why? Half the data's over here and half the data's over there. It's the middle number. What percentile do you think you got here?
75.
The 75th percentile. And I guess the max would be represented by the 100th percentile, right? We don't have to write that. But yeah, like the max. Yeah, you're the max.
So
You're the highest.
percentile doesn't just only detects the position, not the number. So 87%. So somebody can have a score like 75 in the
That's
test,
right.
but it could be 87%.
Mm-hmm.
Okay.
Very good. All right, I'm going to get some data. We're going to go to a data set in the book. If you don't have your textbook, no problem. We'll just write down the page where this data is from. Let's use technology to get these 5 numbers. Although I think we won't have any problem getting the mean, the min, and the max, right? And when I was looking at this today, and I thought, here's a good problem. It was on page... Give me a sec. Where did I see it? It's actually on page 175. So when I'm now, it's funny. Page 175, I'm going to use the data set. Can I erase the material on the z-scores? Are you sure? Awesome. Because we're done with z-scores for the day. We're done with z-scores for a while. Because now we're getting into data that's skewed left, skewed right, or it could be bell-shaped. Doesn't have to be. And when I'm going to use this data table, and there's data here, now this represents the data shown in table 17 shows the finishing times of the men in the 60 to 64-year-old age group in a 5K race. So in 5K race, anybody ever run a 5K? It's like 3.2 miles. But how old are these men? So don't make fun of their times. Don't be like, man, they're slow. Because they're like 60 to 60 years old. I'm shocked they're even running at that age, you know? I'll be just sitting on the couch. Right? So it's pretty good. All right, so here's the numbers. It's on page 175. I could write them on the board. How about I just type them in the calculator? If you don't have your book, you can type them with me. We're going to put all these in L1. All right? We'll do this. It won't take too long. Do you need me to hit the lights? It looks a little better, right? I'll hit the lights, everyone, just so if you don't have a textbook, you're like, can you just put those numbers in there for me? I'll type slow too, but it won't take that long, everyone. Few men ran in this race. I'm going to go to stat and hit enter. Oh, I got to clear this out. You know what I do? I up arrow to L1. I hit clear. Don't hit delete. And hit enter. There we go. All right. But here's the first time. 19.95. Wow, that's pretty good actually. Someone busted 20 minutes, age 60 to 64. That's impressive. That's pretty good for 5K. I'm going to go... gosh, they seem sorted all over the place. I think I'll just go by the columns. So 19.95, 28.58, 33.23, 23.25, 28.72, 33.53, 23.32, 30.18, 36.68, 25.55, 30.35, 37.05, 25.83, 30.95, 37.43, 26.28, 32.13, 41.42, 42.47, 49.17, and then ouch, 54.63, that would be me. Close to an hour, right? 54 minutes. 54 and almost over a half a minute to do the 5-kilometer race. And there's 21 data values here, 21 scores, there's 21 in here, because I can see it's, and when you look at the, it's telling me this is at location 22, so that means that was location 21. Looks like I didn't miss any numbers, and that's good. And then I'm just going to hit quit. Once I got all this in here, I'll just hit quit. So I'm going to do that now. Everyone's second mode is quit, right? Now, do you remember the cool button on the calculator to give me all these? It even has the Q1s and the Q2, and the Q1 and the Q3. It's one variable stats. So I'll go to the stat button, arrow to calc, hit enter. And everyone, I can just hit enter now, it knows to read L1. I'm going to do something though. Let's say you like keeping things in certain columns. If I hit, you don't have to do this, but if I hit second 3 on this front screen, L3, and I hit enter, which column will the calculator read? L3. But I'm not going to put that, so I'm just going to hit delete right now, just to clear that thing out. Stat calc 1. One variable stats. I'm going to hit enter. If I don't hit anything, the default is it knows to read which list? L1. It will know, the calculator will know to read L1, right? But if you ever lose a list, and you can't find me to help you get it back, just put everything in L2 and just put an L2 after that. You can find it on the front screen. All right, let's put these numbers down. I don't see them though. Where are they? I need to use the down arrow. Very good. You got to use the down arrow. All right, let me down arrow. All right, there's the min. 19.95. I guess I can hit the lights now. 19.95. This is in minutes. And then the Q1. Oops, that was the min. 19.95. The Q1 was 26.055. The median is 30.95. The Q3 is 37.24. And then you have the max, 54.63 minutes. And there they are. The 5-number summary, that's it. You can use technology to come up with your 5-number summary. Of course, we could do it by hand as well, if you prefer. Have like a scientific calculator. I know, I'll use that. Not hard to do. Any questions on that? So hey, in your notes, we're done with 3.4. We're now going to 3.5. Well, what's that on? Boxplots. I bet a lot of you had Boxplots before. You probably heard them as box and whisker plots. You heard of that? Yeah, we'll just call them Boxplots. This is another way to represent data. Now, when I made fun of stem and leaf plots, they're kind of lame. Boxplots are pretty cool. Boxplots tell us stuff when we look at the image that we don't see in like a histogram. That you won't see in some of those other displays. You know, the pie chart, histograms, we get a lot of those. Boxplots are pretty cool. Well, we're going to build one. So we're going to talk about the step-by-step procedure to come up with a boxplot. And now a couple times already in this course, I've mentioned the word outlier. But so far, I'm just saying, what's an outlier? Some data value that's just way, way out there, right? Maybe really, really high or really, really low compared to all the other numbers. Well, today we can come up with a math formula to determine whether or not we have outliers. Isn't that cool? So there's actually an actual math formula for that. So we're going to construct a box plot of the data values we have. So I'm going to construct a box plot for all the data we had. It was data on page, was it 175?
Yes.
So I just want to let you know, so if in your notes you're like, where do we construct this box plot? Where did we start? Well, like, we used the data that was located on there. So you go down tonight, you could construct your own box plot. If you have the data, you find the data on the internet. So it's a nice data table that we use, has the 21 values. Well, these are the numbers we use to build our box plot. First thing is, how about step 1? We have to make a scale. We need a scale, everyone. I don't care if you scale it at the top or the bottom, but I'm looking, what's the lowest number about? Close to 20, 19.95. The highest got up to about 54.63. I'm thinking of my scale, everyone. When I build my scale, I'm going to start at like 15. And I'm just going to go by 5s, and every 5 I'll make a tick mark. 15, 20, 25, 30, 35. I'm just trying to spread these out evenly, going by 5s. 40. If you want to put separate tick marks each time, you can. 45, 50, 55. I think that's as far as I have to go, huh? Yeah, this is spread out roughly evenly. That's good enough. This one's a little bit too far. There we go. All right, that's good. There's my scale. If you want to use a ruler, that's even better. You put these little tick marks. If you want to put the 16, 17, 18, 19 there, you can. That's our scale. All right. So now we're going to build this box plot. We're going to construct it. We'll create it. Where do you start? And we're going to start with the Q1, the median, and the Q3. That's the next step. So after you made your scale, you go, what's step 2? Go find your Q1, your median, and your Q3. We're going to put vertical lines. Yeah, all right, what's the Q1? 26.055? That would be about right here. I'm just going to go a little bit up, maybe right here, and I'm just going to put a vertical line. That's it. Here, I'll label it. Your Q1. Just a tiny, tiny vertical line. Where's the median? Oh, 30.95. Do the same thing. Make a vertical line right at 30.95. That's about right here. I like to always label these. There's my Q1. There's my median. You might put the numbers too here. 26.055. You were 30.95. One more vertical line I need. The Q3. Where's that? 37.24. All right, that's about right here. Q3. And then build a box, which is a rectangle. Just build a rectangle with those. It doesn't matter how wide your rectangle is. That's the box. So we're almost done with the box plot. But we're not yet done. The rest of this stuff's important. So that's the box. But that's the first step, right? Get my scale, these 3 numbers, make a rectangle. Cool? Everyone okay with that? All right. You go, what's the next step? Didn't I call this a box and whisker plot? Yeah, we get these whiskers. These whiskers are going to come off here, like that. We're going to draw whiskers to see how far it kind of shows a representation of the data. But on our next step, it's not the whiskers. There's something we got to do to figure out how far we're going to put these whiskers in terms of starting from here. The distance, I'm going to draw it out. So, once I finish my box, would you put this down? My next step is to find the fences. I call them fence lines. To find your fences. That's the next step. I can't draw the whiskers without my fences. I need the fences. Okay? Do you have formulas for the fences? Oh, I sure do. So, there's an upper fence. Way over here somewhere, there's a lower fence. And what are these fences for? Are you ready? Any value that's outside the fence lines are outliers. So now we have a definition for outliers. Any value that's in that data set that's outside the fence lines is an outlier. That's why we're putting these, that's why we're getting these fence lines. They're called fences. I call them fence lines because in our day we're going to look at them as like some vertical line. Cool. So any value outside the fences. What do you mean? Like outside the fence line? From here. Here's all the data's in here, but you can have these fences. If it's outside of it, outlier. If the fence is over here, if it's way over here, it's an outlier. You can have low outliers and high outliers.
So is the fence from 1995 to 5463 in this case?
Yeah, when we build this fence, it's considered net scale. But watch, sometimes, don't be throwing all of ours. You do your math, you get a fence that's like negative value. You go, okay, you might draw your, hey, here's my fence, it's over here. Which means you're probably not going to have any outliers over there.
Go.
But it all depends on the data that you have. So what's the formula? I'm going to start with the upper fence. I'm going to put it over here because the upper fence is on this side. UF for upper fence equals, it's based off the Q3. The upper quartile, Q3, plus 1.5 IQR. And I know you're sitting there right now going, what the heck is IQR? I haven't told you, I gotta tell you. But I'll let you write it down, and that's the math formula for the upper fence. It's gonna be Q3, that number right there, plus 1.5 multiplied to the IQR. So what the heck is the IQR? The IQR stands for the inner quartile range. I'll say that again. IQR stands for the inner quartile range. So if you and I are going to get this upper fence value, and do this math, I know what Q3 is, but we need this IQR. We've got to do that first, don't we? That's okay. We can do it, then we'll get to Q3. So the interquartile range. Now it has a math formula. I just have a feeling a lot of you in this class know what it has to be. Do you remember the word range? Range was max minus min. So if this is titled the inner quartile range, which two do you think you're subtracting?
Q3 minus Q1.
The quartiles. So in the formula for the inner quartile range is Q3 minus Q1. It's Q3 minus Q1. It's called IQR. Nice acronym, right? Easy to say. IQR. Hey, that's on a formula sheet. It is, so you can use it. Hey, what do we get then? What's the IQR?
11.
Oh, I heard 11.185,
185.
and I heard 2 of you got that? So everyone, they took this number, and they subtracted that number. They took this number here, subtracted this, they got the inner quartile range. It's always positive, because you're taking an upper minus a lower. It's always going to be a positive number. So I'm going to do the math here for the upper fence. The upper fence will be 37.24 plus 1.5. And what, do you want to talk like a statistician? Listen how I say this. Q3 plus 1.5 IQRs, plural. Like standard deviations, plural. That's how they talk. They talk them as like IQRs. Interquartile ranges, IQRs. So I'm going to 37.24 plus 1.5 IQRs. Well, IQR was 11.185. All right, what do you all get? Ooh, thank you. 54.01?
I just did mine as 11.185.
Oh, okay. I'll see what other people get. It's right there, though. You're right there. That's 2. 54.01? All right. That's it. That's the upper fence. Now, what do I do? Everyone, you look through the textbook, you won't see any markings for an upper fence. But I'm telling you, everyone, I think we should mark it somewhere. I mean, come on now. We did all this hard work to find it. A fence is like we can see a fence. Let's make some marking. This is what I do. I just make a light dash. Almost like a dotted line, just to represent that fence. And that's what I'm going to do. So I'm going to go over which 54.01. Is that right here? So I'm going 50, I'm thinking 51, 52, 53, 55. Right here, I'm just going to go like this. I used the yellow chalk too. I'm title this UF. Does the book do this? No. I think we should make some marking. Because what did we say earlier about outliers? Any data value that's what? Outside the fence line, it's an outlier. So I bet you already recognize, I think we have an outlier in this group. The slope over. Mid. That'd be mid. This dude right here, everyone, I think he's an outlier, right? He's an outlier. I don't know if there's others. I have to go back and look. But I know for sure he's higher than that. So we're going to have an outlier. Now let's do the other fence. What's the lower fence formula? It's similar to this, everyone, but it's not going to have a plus. It's going to have a minus, the lower fence. And it's not going to be Q3. We're going to use the Q1. All right? So I'm going to go over here. Can I erase the IQR work? Remember, the IQR was 11.185. So I'm now going to get the lower fence. And the lower fence, here, just call it LF. LF equals Q1 minus 1.5 IQRs. So I'll take the 26.055 minus 1.5 times 11.185. So Art, if this came out negative, don't be shocked. It's just, we're going to say there's no outliers on that side. We'll just put a fence.
It came 9.27.
What was it?
9.27.
And look, it's outside our scale even. Isn't it? When we just started creating a scalar, that's totally normal. It's just at 9.27, I'm going to put a dashed line with the yellow chalk. So I do have to extend the scale a little bit. I'll go out here to 10. And then right before that 10, I'm building a fence. There's a fence line right here. The lower fence. It's my LF. But did anybody run this race faster than 9 minutes? No outliers over here. But we do have an outlier there. See, sometimes, I mean, yeah, we know this, just some people are just really fast out there. He's an outlier, she's an outlier. She can run the 5K in 10 minutes. In this case, you had to do it faster than 9 minutes, though. Which is crazy. Doing a great job so far. Everyone okay with the fence lines? Hey, so just recap the steps, because we're going to get the whiskers in a second. I guess I built a scale. I built my rectangle off these 3 numbers. My next step, I found my 2 fence lines. I found the upper fence, lower fence. The formulas are provided on the formula sheet, and I find these values. And we know anything beyond the fence line is an outlier, right? So finally I get to draw the whiskers. Okay. Not hard at all. I will return to my white chalk. I only use the yellow chalk for the upper fence lines. And I go right off the middle here and I draw a whisker. Now this is where students get confused. So I just want to be clear on this. And let me know if you have any questions. Just raise your hand. I'm going to draw this whisker. I'm like, okay, well, how far are you going? Started out, I'm going to start drawing. You go, well, how far are you going? Students mistakenly think that you always draw it to the fence line. That is false. That is false. You go, where am I going to? I have to go back and look at the data. I'm going to start drawing my whisker. I'm going to go to the value. I'm going to draw it to the value that is closest to but within the fence line. Can I say that again? Mm-hmm. I'm going to draw this whisker and keep going, but I'm going to draw it and stop this whisker. At the data, I have to go back and look at the data. The data value that was closest to this fence line but within it. So that means I'm going to go back to this calculator, right? And I got to dive back into the data. I got to go look in L1. Which number in L1? Stat, edit. Which one was the closest? Some of you may sort this, but you might find it. Who was the closest, all these numbers, who was the closest to 54 but lower than 50? So closest to 54 but within it.
49.17.
Well, I'll go find it. By the way, there's a sort button for this if you want to sort it. Is that it? Mm. So if you're like, man, it was taking me too long to do this. If you want to follow me, you go, how do you sort on here? I'll hit quit. I'll just hit clear. If you go stat, before I hit edit, have you ever looked down here? What's this say?
Sort.
Sort A, sort ascending, sort D. So you go, all right, I'm going to hit number 2. If you want, you don't have to do this. I go, okay, sort A. But guess what I have to put in parentheses? L1. L1, where is it on the front screen? You got to hit second one. I hit second one, and I go, I don't even close out the parentheses because I don't feel like it. Although you could. Done. So it did it for me. Let me go back and look. Stat, edit. Ah, thank you. Now it's sorted. It looks nice and pretty. Thank you. And which one was closest?
49.
Closest to 54.01, but with
49.4.
So in that number right there, I'm going to stop my whisker there. Does that make sense? So I'm going to draw this whisker. Here I go. Where am I stopping? Keep going, keep going, keep going. Where am I stopping?
49.47.
Right there. Right there. And I actually like to label it. I want to tell you, where did I stop? So if you're trying, like, I stopped at the value that was closest to the fence line, but within. So hey, probably the most common error on a box plot. Students mistakenly think this thing always reaches the what?
Outlier.
Fence line. Yeah. Now, could it reach the fence? It could. It doesn't happen often, but I have to tell you what would happen. It would have to be a miracle where, you know what happened? You and I found that number, and my gosh, that funny number right there is actually sitting in the what?
Middle.
Data set. Oh, okay, then draw it to there. Actually, you know what? That happens on your homework problems, so don't freak out about that. There's a cool problem on the ages of the presidents when they were inaugurated. You know, they're all like 46 years old and 54, and they got someone up in the 70s, you know? Like Reagan was really old, and James Buchanan was really old, but JFK was only 43. And let's see, Teddy Roosevelt, everyone, he became president when McKinley was assassinated. He was vice president, he was only 42. So you got ages around 42 to like 73, and one of the presidents is an outlier, and it's Ronald Reagan. So you can do that problem. But you're going to notice when you do it, you go, oh my gosh, the fence line is an actual number in the data set. All right. Hey, so help me do this with it. Does it go all the way to the 9? No way! And then you would be saying you got data way over here. Where do I stop? I stop at the number that's within the fence line, but closest to it. Which I guess in this case is going to be the what?
19.9.
Yeah, the 19.95. So I'm going to stop right and I'm gonna label it. Awesome. Awesome.
So then our max is an outlier. Do we have to mark?
I love it. We have to mark it.
Okay.
So to finish this whole project, are we done? Well, we're like 99% done. There's one thing we have to do. We have to mark any outliers. You go, what symbol to use? I like to use an asterisk. I like to use this thing. But maybe you like hashtags. You can use hashtags. You can use any little symbol to represent your outliers. I said outliers because sometimes see how you get more than one. You get like 3 outliers and stuff, okay? But in this case, there's only 1 outlier. It was this time right here. Let's make a mark right here. Let's label it 54.63. But that little symbol means it's an outlier. Cool. If anybody in this room right now works for some organization or any company or something, you know what would be neat? Me included. I would like to see it for myself. A box plot for the employee salaries for the entire organization. From the lowest to the what? To the highest. Because I'd be curious, are there any outliers, right? And you can think about it in terms of myself right now. Just like, I wonder who would be an outlier. Are there outliers? All we need is all the data, right? And you go, yeah, but is that public information? Actually, it is. Actually, you can get that stuff. Okay? All right, so, is everyone okay with all this? Hey, we're going to do 2 things before you leave. The first thing is we're going to talk about the beauty of the box plot. And then the second thing is, let's talk about, can you use the calculator to do this? So the first thing, the beauty of the box plot. Why do I like these? Because they tell us stuff that's not in the histogram and stuff like that, the pie charts. This tells us about percentages. So, everyone, in this whisker right here, 25% of the data lies here. In this section of the box, 25% of the data is in there. In this section of the box, 25% is in there. And where's the remaining 25%? Because everything has to add up to 100. From here, I can't stop here though. Why? There's a what?
Outlier.
Yeah, so let me go all the way to the outlier. I'm like, all the way to there is the remaining 25%. This is the beauty of the box plot. I can look at a box plot and see stuff I don't see in the history. Holy cow, and listen to me. 50% of the runners ran between a 26-minute and a 37.24-minute 5K. I know that right away. So if this is what I'm talking, you look at salaries, it's shocking. You're like, oh my gosh, half the employees make less than this amount. You're like, oh my gosh. Or half the employees, 25% of the employees? If I was thinking ACC, I'd be like, there's numbers up here. I'd be like, oh my gosh, 25% of the employees make more than this? I had no idea. So it really kind of stands out. It's pretty cool to look at some box plots. Plus, when you do comparisons, you put a box plot of men versus women, right? It could be cholesterol levels, something like that, but you're doing some kind of comparison. So the beauty of the box plot, percentages. Cool. Hey, do you all agree? Is this a true statement? 75% of the runners ran 37.24 minutes or less. Is that true?
What was the thing?
Oh, let me say it again. 75%, look at the picture. 75% of the runners ran that race in 37.24 minutes or less.
Yeah, that's true.
Yeah. 25% of the runners ran it in 37.24 minutes or higher. Hey, is this true? Half the runners, 50% of the runners ran that race in 30.95 minutes or slower.
True.
Right? Slower, I'm thinking quicker. Do you agree?
Mm-hmm.
I should say faster, right? Yeah, my apologies. I should say 30.9 minutes slower, you're over here. And when 50% of the runners ran that race in 30.95 minutes or faster. True statement, right? Beauty of the box plot. But hey, maybe you want to build these with the technology. It's not hard at all. Let's go in here. I'm going to hit the lights, okay? Randy?
They will always equal 25%.
Always.
Always.
Isn't that cool? Beauty of the box. That's what I like about it. You know, it's what I really like, Randy. We don't see this in a histogram. Now, unfortunately, I don't see many box plots given. But boy, are these cool. I'm being honest when you're talking about salaries. So this thing looks awesome if you're doing like NFL salaries. Or you're doing Major League Baseball salaries. See, Major League Baseball, you got a bunch of outliers. Because there's a few players that make a ton more than what? other players. There's been times there when where one player made more than the entire team.
Well, Bill
You know?
Gates in his Harvard class.
So it is amazing, yeah. So we'll talk more about Boxplots. All right, I want to go to your calculators. We already got everything in L1, right? Everything's already in there. So this is the first time we've been here. We want to draw a plot. We need a plot. The button is called Stat Plot. This is the first time I've ever gone here. I'm going to get off this screen by hitting second quit. I'm going to clear out this screen, and I'm going to hit second Y. It's called Stat Plot. So it's second in the upper left button. And the first thing I have to do is turn it on. Okay. I hit enter. How do I get the lock on? I just do what? I hit enter. There we go. Now look at these. Which one looks like a box plot? I see two of them. There's two of them. These two. Which one do we want? We want the one that's more scientific. The one with the outliers. Do you see it?
Mm-hmm.
The one with the little beep beep. It's got those two little outliers. That's the one we want. This would be one if it just didn't do any outliers for us, right? So that's the one we want. So let's go there. How do I move it? You got to use the left and right arrows to actually move it. Once you enter down, so I enter down, downward. Now I use the right arrow. There we go. Now how do I get the lock on there? Hit enter. Now watch when I hit enter. When you watch carefully, I'm going to hit enter. Watch what happens to this. Watch it change. So it says L1, L2 right now. I'm going to hit enter right now. Did you see it? It's a smart calculator. It knows that I've got everything in L1 when I'm doing Boxplots. Boxplots, it knows only to read one column. Well-designed calculator. It goes, okay, Boxplot, we're only going to read one column. And when you're okay with this marking for outliers, I am, it's fine. Now, hit zoom 9, because this will zoom in on your statistical data. Zoom 9 is called zoom stat. And I'm going to hit zoom stat to zoom in on my data. Zoom 9, all right, where's zoom? Zoom, and then I'll just go down to zoom 9. Zoom trade, no, zoom standard, I like zoom stat. And you enter. And there it is. Cool. Now how do I get the numbers to pop up? I have to hit trace. I want to see the numbers, right? Doesn't that look like that? Yeah, it looks just like that. I want to hit trace. So I'm going to hit trace. And I'll use the left and right arrows.
What is
That's
trace?
what we got. Oh, trace is in the very top column, closer to the right, next to zoom.
Okay, go.
And then you can move your left and right arrow. Ooh. This is great. I mean, we did all that by hand, but this does it all for me. This is cool. We're not, and there's the lonely one. Outlier, there it is. We move back. And of course, when you do this, I do get students, they might be sitting here right now, and they're like, my calculator's not working. When class is over, come up and show, I'll help you fix it. It's probably, you know what can cause glitches? Maybe we got a brother or sister who uses this. Maybe you got like a toddler around the house. They love to get in these calculators. And if they go into like the Y equals and put stuff like this, that kind of stuff can throw out and lock it up. So I'm going to hit clear. Sometimes this kind of messy stuff can make it lock and not work. So if I hit zoom 9, I got my little screen right there working. Isn't that cool? Hey, oh, one more thing. I might as well leave that up there. Last thing, I'm going to leave this up here so you can see this. Do you remember skewed left, skewed right, and symmetric? All right. Hit on. Zoom 9. We go, what does that mean? Well, if you got data that looks something like this, that's going to be skewed to the right. If you got a box plot that looks like this, where it's longer whisker on the left side, that's skewed to the
Left.
left.
And the center.
And what do you think this would be if I've got a box, the median is almost roughly in the middle of the box,
Bill.
and this whisker is almost the same as this whisker? What do you think that would be?
Bill.
Bell shape. So, everyone, what would you interpret that one on a test? What would you
Bill.
say? And you can use the word roughly if it's a close call. You know, if you're not, that's roughly what? Skewed to the, I think it's roughly skewed to the right. Now you want to make sure? You want to have fun with this? It'll only take 2 clicks of the calculator. Can you see that art or should I hit the lights?
Shade the lights.
I'm going to hit the lights. I want to have a little fun to make sure this is skewed to the right. So watch what I do. I go, I want to make sure, is this skewed right? It looks skewed right. I'm going to go back to stat plot. Hit enter. Which one of those looks like a histogram? Which one of those?
Third one.
I'm going to hit this and hit zoom 9. Oh, it's skewed to the right. Oh yeah, baby, right? Now this thing's skewed to the right. Can you see that? Do you agree? Now, see, I can just change. You could change from a histogram back to what? Oh, let me put it back. I'll go back here, down here, and put it back to my cool box plot. Zoom 9. You can go back and forth. But I want you to see skewed right, skewed left, symmetric. Man, everyone, great job today. If you have calculator issues, I left some time here. You come on up. I'll help you out, all right? Have a great day. Stay safe driving.